there's got to be some sort of real world financial scenarios, typically, most of the time, how this goes down, right? So how are we trying to optimize a process or sort of reduce costs, increase sales, increase conversion rates, that kind of stuff like that. So often there's some justification, and then we back into the problem, or we back into the solution based on what the problem dictates. Okay, and in day 5, we're going to talk about how we deploy these things. So we build these models, right, and then we optimize them. We get them to where they're actually very accurately making predictions, accurately enough that where it's better than what we're currently doing. And then we want to deploy these into the real world and actually use and consume these in our everyday. So if we have an algorithm that determines who are customers that are likely to download software, Pragmatic Works software, now we're going to put that in some marketing tool where now we're going to begin to communicate with those people. And so that's the whole concept of putting this out into production, as well as once you get it out there, all models will decay over time. So they don't, once you build a model, it doesn't say it's not locked in forever. Everybody who has an iPhone 4 is a bleeding edge technologist, right? Well, at some point the iPhone 5 comes out, and people who still have an iPhone 4 are no longer those people. So we've got to continue to maintain and deploy new models over time. So this is a big piece of it. And when we get into the data science process, we'll talk about how every stage of this process is critical to building the prediction capability within an organization. So that basically talks about what the week is what's going to come down to. My expectation for the people in this class is that you're not going to be an expert at predictive analytics at the end of this class. I don't think anyone probably expected that either. But what I want to happen is that you're going to get this exposure to this. It's somewhat an intimidating topic, at least it was for me the first time I got into it. Because the majority of the people that were in this space were mathematicians and statisticians and people with PhDs in other fields, and then companies like Google and Amazon and Microsoft and Apple and all these, would just go out and hire these guys who had a PhD in biology and say, just come here and mess with my data and see what you can come up with. And people in the academic field are they're a little bit different than the people in the business world. They have different drivers, different motivations in how they work. They're mostly researchers, and they do a lot of writing. And the documentation and whatnot that they write are oftentimes very difficult to read. I just finished up grad school and I had to read a lot of their books, and it can be challenging. And what I wanted to convey with this class was that it didn't have to be challenging, right? It's especially as the tools get better, as the processes get better, you don't need to understand all of the mathematics, all the statistics, even though it's certainly, you're going to need to know some of that eventually to become really good at this. You don't need to know that to get into it. And oftentimes it's intimidating, and it's a barrier to entry for some folks. For example, these are just some of the books that I have in my own personal collection. Some of them are from school, some of them are just other things that I picked up along the way. This was the first data mining book that I ever bought. I bought this many years ago, long before I ever got into this space, because if you've been in the data business, you have heard of data mining, right? I mean, it's kind of a cool thing. By the way, data mining is the same as machine learning, same as predictive analytics. And it just sounds cool. I mean, who would want to turn on an algorithm that would just go through the database and find something interesting that we can monetize? Doesn't necessarily work that way. But nonetheless, I went through this book and I was excited, and I started reading it, and I went through, and it's written by a guy who's some PhD from New Zealand, Australia, I think is one of his buddies. But it's so hard to read. Within the first few pages, we're looking at all kinds of Greek letters and mathematical symbols that I remember from school, from college, and some of my advanced class, but I often had to pay attention to it. And about halfway through the book, I was probably understanding every other word, and it wasn't sinking in, and then I never finished the book because I couldn't synthesize the information. Now that's just me. I mean, some of you, may not, maybe a lot smarter in that space. So put it on the shelf. I never returned to it. That was the intimidation factor. So that was well, let me just continue doing this BI stuff for right now, and then I'll come back to this. Just because I couldn't understand it. What I want to do with this class is make it understandable. Okay, to get you sort of over that hump. At the end of this class, you will have an exposure to what predictive analytics is, what machine learning is, what Azure ML is doing for you. So a lot of you are programmers. At least you have done programming at some point. I highly doubt that anybody can write code, write binary code, write ones and zeros, right? That's ultimately what the compilers do. That's what .NET does. It compiles it down to an assembly language, and then that gets interpreted by a compiler that then converts it to ones and zeros, and the computer does something. You don't need to know how to write in ones and zeros to be a good programmer, right? And we have fourth generation languages that are really easy to write program. You can get a web app up and running in a matter of minutes, a simple one. You don't need to understand all that. So that's what Azure ML is doing for you behind the scenes. You don't necessarily need to at least get started to understand what's going on behind the scenes, which I think is really cool. So at the end of this, I think you'll have that exposure. You'll have gotten over that hump. You'll have been exposed to what real-world analytics looks like. So I had a professor. So I had a lot of professors that were academics and researchers and that kind of stuff like that who lived in laboratories and stuff. And it was difficult because I have a lot of years of experience in consulting. I've been doing this for a long time. And when you're in consulting, you understand that you've got to show results. Like you don't have 6 months to sit around and come up with something interesting. Typically, there's a very distinct project objective, set of requirements that you get to. So you hit the ground running, and you have to show value from day one and continue to show value. A lot of the academics in this space, they're motivated differently, right? They're motivated. They're researchers, so they're different than what we're accustomed to in the business world. So I tended to try to lean toward professors that were actual practitioners, people that were actually in this field making money, actually doing the work. And I actually came across one, and one of the things that really sort of gravitated toward him, one of the things he did was, all right, here's what the curriculum is for the class, but here's how it really works in the real world. This is how, if I were at a client and we were trying to solve this problem, this is how we would do it. And that was immensely helpful to me, and that's what I'm trying to do here with you guys is not only expose you to this, but also give you sort of real world experience of how you would literally, if you were sitting in front of your boss or sitting in front of a client or something like that, this is how we plan to tackle this problem. This is how we know when we've got to some resolution. But at the end of this class, you'll have some knowledge, but it will be necessary for you to continue your process. And these are some of the books that I literally go to on a regular basis for answers and stuff like that. Some of these are R books, some of these are Python. Some of these are just off the wall, boring. Like I'm actually reading this one right here, Applied Predictive Modeling. This is the guy who's written quite a few packages in R. It's a pretty smart guy. Stuff like econometrics is just boring. I hated this class, but there's some interesting stuff in it. It's definitely useful in the world. And these two books right here, ones that I'm still working on, I'm hoping to be able to take over the world by cornering the stock market. Right? Actually, this guy was one of my professors. I had for statistical and financial engineering, right? So there's a lot of analytics in here. What's interesting about the finance world is that it's real hard to build predictive models in the finance world. Otherwise, somebody would be doing it and they would have the market cornered. But what it forces you to do, and we'll get into this topic a little bit, is it forces you to become simpler on your thinking, right? So we've all heard about these global warming models that predict in 10 years temperature's going to go up by 100 degrees or whatever. You know, they these models on top of models on top of models, and they're very complicated. And every assumption, every parameter in that model has to be realistic, and otherwise it just creates these crazy forecasts. But in the finance business, you can't do that because you have to backtrack that down to make the more simpler models. So there's a law that we'll get into, and we'll talk about a little bit, that says the simplest model is the best, and that's pretty much true in everything we do, right? We tend to want to overcomplicate things and make them difficult, and we want to add all these layers to it. But oftentimes, the simpler model is typically much more accurate because we're attempting to forecast or predict the future, which is unstable and full of variation. We not necessarily can't do that with these complicated models, and we'll talk about it a little bit. So does anybody have any questions? And you guys are free to come up here and just kind of poke around, look at these things, and let me know if there's anything in particular that you have questions about. Does that make sense so far?
Makes sense.
Any thoughts on that, Devin?
I'm recording you.
Okay.
I'm showing it to the world, actually. We're live streaming this here.
Okay, so that was kind of my introduction spiel to this. You guys are here because you have some background in data science or predictive analytics, at least from a knowledge. You know what it is. You've heard of it, right? You're not just here by accident, unless you're Tim and you just were walking by and somebody grabs you. So like any whether we're building a data warehouse or we're building a CRM system or anything, there's a process around it. There's a project management process. There's an implementation process that is critical to getting it right. It's critical to capturing requirements and focusing the project on what we're trying to do. And in the predictive analytics space, we call it the data science process. How do we go from some business or some institution has a problem, and they're looking to optimize that problem through analyzing data. Okay, so that's what we're hoping to achieve in the data science process. We're going to go through this whole thing and come up with an answer. So there's some discussion points that we're going to go through. What is data science? It's a buzzword. Some examples of data science. Whether you realize it or not, your world, it surrounds you right now. There are predictive analytics, things that you do. If you've ever gone to Amazon.com or eBay or Google, for that matter, you have participated in some way. And we're going to talk about statistics versus predictive analytics. They are not the same. And then we're going to talk about what data science is not. Okay, so there's a lot of unknowns, or what does it do? What does it not do? What's a realistic expectation from this process? All right. So what is data science? It is the process of extracting knowledge from data. So we're going to explore large amounts of data and search at meaningful patterns and rules. Especially nowadays. Again, you guys all have data backgrounds. And being from pragmatic works, you all have data warehouse background, BI, which is oftentimes large databases. Right? So we understand this problem that we continue to capture more and more data. We've all heard the big data term, and that's another. Data science is a buzzword, but so is big data. What does it mean? That kind of stuff. And what's happening is that we're capturing vast amounts of data for the purposes of someday being able to do something interesting with it, right? Oftentimes what happens here in the BI space is that we capture tons of data and we just aggregate it up and see how we're doing, how our sales by quarter, by region, or something along those lines. So data science, we want to go through this data and extract some sort of knowledge out of it. So it's basically the components that make up data science is mathematics, statistics, and computer science. If you don't have a background, and so one of the things that people will ask is, what are some of the building blocks I need to get started in this? And statistics, in my opinion, is very important. I had statistics in college many years ago, and I loved the class. That was awesome. At that time, I had no idea I was going to get into the business intelligence space or the data space. I was in the MIS program, but I had no idea where that was going to lead. But I remember it loving. I had stats 1, stats 2, and then I never revisited it. And to this day, I look back and go, well, why didn't I do more of that? I think it's cool because statistics are things. Forget data science, forget predictive analytics. Statistics are something that dominate our lives, right? One way or another, whether it be through media research or through things that happen on around us. And I think it's critical to have a basic understanding of statistics. Most of you probably had a sort of a ground level. I had stats or had a class that was part of stats or something like that, and so I understand averages and I understand standard deviations and I understand that sort of thing. I would recommend getting to know stats a little bit better for this because I think it's going to help you out. And we're going to talk about some of those basics in this class, especially when we get into building some of the machine learning experiments and what part of statistics are important, that kind of thing. This is a book, Stats for Dummies. I actually started reading this book before I got into the data science predictive analytics space. It was a great book, but I remember reading through it, and some of it was useful, some of it wasn't, but I would definitely recommend getting to know this. Mike, you and Gina, I definitely want you guys to get this. Again, you don't need to be a statistician, right? There are people that do that, and that's not something that's interesting to me. It is very useful and interesting to others. But I would get to know the basics, like a dummies book or beginner stats. So there's a ton of them out there. They don't really cost much, but I would definitely get to know that. So there's just some more concepts: machine learning, predictive analytics, information theory, statistical analysis, Monte Carlo simulation. Anybody heard of a Monte Carlo simulation? That's a term that's out there. Data mining, probability, all that sort of stuff. So there's a ton of little terms out there, and I'll probably accidentally interchange them within the class when I'm up there speaking. So if I say machine learning instead of data mining or something like that, know that I'm talking about all the same thing. The only caveat is we'll talk about is statistical analysis is different than in data science, and we'll get into that concept here a bit. Okay, so what is a data scientist? Is it a real scientist? So sort of the way I understand it, the genesis of the term, the topic, was companies with just mad money, like Google and Amazon, those kind of things. They're sitting on mountains of data, right, that they can't figure out what to do with, and so they reach out into the academic world where we've got these researchers out there that do a lot of research, but they do it in other fields like biology and astrology or astronomy, that kind of stuff like that, where they're measuring the distance of stars and that the mineral content of a planet that's 10,000 light years away or something. And the process of a researcher, so a scientist in a university, is they have the scientific process where they come up with a theory and then they run all these tests in hopes to disprove that theory. And if they can't disprove that theory, then they might have something there, right? And so they do a lot of statistical analysis and stuff like that. So that process was very valuable in the academic world. So a lot of these companies who would start research departments, most organizations don't fund research departments because they just don't have millions of dollars sitting around, to do this sort of thing. But these bigger companies do, and so they're going to bring these guys over with a PhD who have this knowledge, this inherent knowledge of how to analyze data. And so they kind of brought over that scientist moniker, but they're no longer working on the mating migration patterns of lemmings. They're now working on how do we sell more stuff to Amazon.com users? And so now they're working with data, right? And so that's kind of where it came from. A lot of them originally had a PhD, but what's happening is that it's become popular in the space. So a lot of schools are starting to come up with certificates and master's levels programs. Even schools are now starting to come out with under typical bachelor level programs for data analysis, data science, that kind of stuff like that. So you don't really get the label data scientist. It's not something that you earn. It's just kind of a funny term. I honestly feel kind of weird calling myself a data scientist. And just I don't know, just who I am. It just feels a little goofy. It feels like I'm trying too hard, like I'm trying to be something I'm not.
You'll really be that way if you walk into your client with like a lab coat on or something like that.
Yeah. So, and really, where that attitude comes from, because I had a couple of professors in school who had PhDs in mathematics, and they felt the same way, and so these are guys who have the ultra advanced educations, that kind of stuff, who work for SAS and who work for other big companies like that are very active in the space, and they kind of talk in the same vein. So